Hello students, let's start with the next questions from Payload chapter equilibriums. So far we have done the first 20 questions. In this video lecture we will do correction. So far we have done the first 15 questions. In this video lecture we will do the next 5 questions. So let's start with question number 16. The performance limited takeoff mass of aircraft is 44,800 pound. Performance limited landing mass is 4,400 pound. Basic empty mass is 3,210 pound. Aircraft is to carry two pilots of masses 210 pound and 180 pound each. Takeoff fuel 106 US gallon, where 1 US gallon equals to 6 pound. What is the maximum traffic load for this flight if the trip fuel is so and so, and 13 pounds of fuel is to be used for startup and taxi? So step 1 is to make 3 columns, one for takeoff mass, second for landing mass, and the third for zero fuel mass. In the takeoff mass column, you are going to write the value which is the less of or the least of maximum structural takeoff mass and maximum correction. Performance limited takeoff mass and ramp mass minus taxi fuel. Correct? So now let's check here. Over here we have been given performance limited takeoff mass 4,800 pound. Okay, and that's it. And apart from that we have been given the fuel used for startup and taxi. Okay, so we have performance limited takeoff mass 4,800 pound and taxi fuel. So for startup and taxi the fuel consumed is 13 pound. So 13. Now, between maximum structural takeoff mass and performance limited takeoff mass, we have to select that value which is the less in number between them. Now, we have been given only performance limited takeoff mass in the question. So, no point of maximum structural takeoff mass here. The next thing is we have the formula ramp mass minus taxi fuel mass. So we have the taxi fuel, startup fuel and taxi fuel mass, but we do not have ramp mass. So we cannot subtract taxi fuel from the ramp mass because we don't have ramp mass. So we have to go forward with the value, final value 4,800 pounds. So this may be your regulated takeoff mass, but we'll go to the next columns for landing mass and zero fuel mass and check what takeoff mass values we get. So moving ahead, landing mass, you have to select, again you have to select that value which is the less of performance limited landing mass and maximum structural landing mass, and to that you have to add trip fuel, right? So now performance limited landing mass is 4,400 pound. We don't have, it's not, structural limited landing mass is not given to us. So stick to performance limited landing mass which is 4,400 pound plus trip fuel. Trip fuel is 86. So trip fuel is 86 US gallon. So the trip fuel consumed is equal to 86 US gallon. Now you have to convert this US gallon into corresponding weight. 1 US gallon equals to 6 pound. So 86 US gallon will be equal to how many pound? So 86 US gallon will be equal to 86 into 6, which is equal to 516. So add 516 to 4400, you get 4916. So this is the next takeoff value. In the zero fuel mass column, you are going to write the formula maximum zero fuel mass plus fuel on board, that equals to, so maximum zero fuel mass is not given to you. Okay, so leave that column empty. So now we have two takeoff values, 4800 and 4916. So out of these two takeoff values, you have to select that value which is less, and that value is 4800. So our regulated takeoff mass is 4800 pounds. So we are going to load our aircraft with this weight. Step number two. Let's go to step number two now. Regulated takeoff mass equals to DOM plus payload plus fuel on board. So regulated takeoff mass is 4800, which is nothing but, so you can make it 4.8 if you want, divide by 1000, or just 4800. So I'll take the whole value. DOM is, so now here the dry operating mass is not given to you directly. They have given you basic empty mass and variable load. Now what is DOM? Dry operating mass is your basic empty mass plus variable load. In this variable load in this variable load you have load of your pilots, after that catering, food, water, something like that. So that is variable load. So substitute the values. Basic empty mass is 3210. Variable load, under variable load you are going to add or combine the values of two pilots who weigh 210 pound and 180 pound respectively. So 210 plus 180. Now add all of that. 3210 plus 210 plus 180, 3600. So your dry operating mass is 3600, payload unknown, fuel on board. Now again, fuel on board is nothing but your takeoff fuel. Now takeoff fuel here it's given 106 US gallons. Takeoff fuel given is 106 US gallons. 1 US gallon is equal to 6 pound. Therefore, 106 US gallon will be equal to 106 into 6, which is equal to 636 pound. Therefore, payload will be equal to 4800 minus 3600 plus 636. So 636 plus 3600 is 4236. So 4 minus 4800 is 564. So the payload is equal to 564 kgs. Correction, 564 pound. Okay, 564 pounds. So correct answer will be Bravo. 16 answer will be Bravo. Yeah. So now in this question, the process is more or less the same. But here the changes that you see are, they have not given you the zero fuel mass directly. So we omit out that column. Next, dry operating mass is also not given to you directly. Basic empty mass is given, variable load is given to you. So you should know all the definitions included, or definitions in the weight and balance chapter. If you know the definitions by heart, you know the mathematical equations, you will definitely be able to ascertain the value of DOM by calculating or by adding basic empty mass and variable load. Okay, and pay attention. Next very important thing is the units used in this question. They have used pound and not kilogram. Okay, it may happen that they may assign a unit of pound to takeoff mass like 4,800 pound, and for landing mass they may assign a unit of kilograms. Okay, so in that case you will have to convert kilogram into pound so as to bring it to a level equal to takeoff mass, or convert takeoff mass unit which is pound into kg, so that both takeoff and landing masses have same units. Okay, so pay attention to the units, and pay attention to the conversion formula given here. So for gallons to pounds or gallons to kg, they will give you the conversion formula. Do the cross multiplication. If they don't do that, use just CX3. Now let's go to question 17. The performance limited takeoff mass of aircraft is so and so. Maximum takeoff mass, meaning it can be structural takeoff mass. Again, it's given to you. Zero fuel mass is given. Maximum landing mass and performance limited landing mass are given. Basic empty mass is given. Variable loads, that is the weights of pilots, are given to you. Takeoff fuel load is given to you, and you have to calculate again traffic load. Similar question. So let's start with your step 1. So step 1 is draw 3 columns, one for takeoff, another for landing, and the third one for zero fuel mass. Now in the takeoff mass column, you are going to use the value which is less of performance limited takeoff mass and maximum structural takeoff mass. So that value will be 4,800. So between 4,800 and 4,850, select 4,800. Going ahead, in case of landing mass column, you have to select that value which is less of maximum structural landing mass and performance limited landing mass plus trip fuel. So now maximum landing mass is 4513, performance limited landing mass is 4400. So between these two, the value which is less in number is 4400. Trip fuel. Now what is trip fuel? Trip fuel is 85 US gallon, right? Convert that 85 US gallon into weight. Now 1 US gallon will be equal to 6 pound. So 85 US gallon will be equal to 85 into 6, just 510 pound. Okay, 85 into 6, 510. So 4,400 plus 510 will be equal to 4,910, okay, pound. The last column, zero fuel mass column, here the formula is maximum zero fuel mass plus fuel on board. Now maximum zero fuel mass is 4470. Fuel on board. Now here it's given fuel on board, that is takeoff fuel, is 110 US gallon. Okay, 110 US gallon. 110 US gallon will be equal to how many pounds? 110 into 6, which is 660 pounds. So what you are going to do is 4470 plus 660, that will be equal to 5130 pound. Put them in boxes. So one is 4,800 pound, 4,910 pound, and 5,130 pound. So out of these three values, select the value which is the lowest, and that is 4,800. So 4,800 becomes your regulated takeoff mass. Step 2 formula: regulated takeoff mass equals to fuel on board plus dry operating mass plus payload. So regulated takeoff mass is 4,800. Fuel on board is this 660 pound. DOM. Now again, DOM is not given to you directly. So DOM will be equal to your basic empty mass plus variable load. Basic empty mass is 3,200. Variable load is 200 plus 190. So add all of that. 3,200 plus 200 plus 190 equals to 3,590. So 3,590 plus payload. Therefore, payload will be equal to 4,800 minus 660 plus 3,590. So 4,800 minus 4,250, which is equal to 550 pounds. Therefore, payload will be equal to 550 pounds. So option A. Question 17 is option A. Okay. Simple. Let's go to question 18. I hope you're uh, understanding what I am doing. Next, question 18. Performance limited takeoff mass of aircraft is 4,800. Maximum takeoff mass is 4,750. So two values of takeoff mass. So between these two values, which is the lesser one, 4,750. So this is the value which we are going to use in a takeoff mass column. Zero fuel mass is given, maximum landing mass and performance landing mass is given. Now between them, the value which is less in number is 4,400. So this is the second value which we are going to use in the second column. Again, basic mass is given, variable loads are given, takeoff fuel load, that is fuel on board, is given to you, and other conditions are similar: trip fuel, startup taxi fuel. Nothing great. So step 1, takeoff mass column, landing mass column, zero fuel mass column. Okay. So what is the takeoff mass column? You have to select the number which is less in value between maximum structural takeoff mass and performance takeoff mass. And that value is 4,750 pounds. In case of landing mass column, we decided to check 4,400 because it is less than 4,513. So 4,400 plus trip fuel. What is trip fuel? Trip fuel is 85 US gallon. Okay, so 85 US gallon will be equal to 85 into 6, which is equal to how much? 510 pound. So 4,400 plus 510 is equal to 4,910 pound. Next, in the zero fuel mass, the formula is maximum zero fuel mass plus fuel on board. So what is maximum zero fuel mass? It is 4,100. So 4,100 plus fuel on board. Now fuel on board is what? Takeoff fuel load. It is 110 US gallon. So convert that into weight. So 110 US gallon will be equal to 110 into 6. 660 pound. So 4100 plus 660 is equal to 4760. So now we have three values. We have three takeoff values: 4750, 4910, and 4760. The value which is least of these three is 4750. This value, right? So this becomes our regulated takeoff mass, 4750 pound. Step 2, takeoff mass will be equal to dry operating mass plus fuel on board plus payload. Now takeoff mass is 4750. So 4750 equals to DOM. Now what is DOM? Basic empty mass plus variable load. Basic empty mass is 3200. Variable load is 200 pound plus 190 pound, the weights of pilots. So 200 plus 190. So 3200 plus 200 plus 190 is 3590. So put 3590 here. Fuel on board was 660, and now find out payload. So payload will be equal to 4750 minus 3590 plus 660. So 4750. Now 3590 plus 660 equals to 4250. So that will be equal to 500. So your payload is 500 pound. The correct option will be option should is the closest option, 510 pound. Okay. Next, question 19. The performance takeoff mass is given. Maximum takeoff mass is given, and maximum zero fuel mass is given to you. Maximum landing mass is given. Performance landing mass, and all other conditions are similar. Okay, so you have to find the maximum allowable traffic load for this flight. Okay, so let's make the three columns: one for takeoff mass, landing mass, and zero fuel mass. So in case of takeoff mass column, you have to select the value which is less of performance limited takeoff mass and maximum structural takeoff mass, and that value is equal to how much? It is equal to 4950, because 4950 is less than 5000, so you are going to use that 4950 pound. In case of landing mass column, a value which is less of performance limited landing mass and maximum structural landing mass plus trip fuel. So that is equal to 4513 4500. So between them you are going to select the value 4500. So 4500 plus trip fuel. Now what is trip fuel? Trip fuel is 85 US gallons, right? So convert 85 US gallon into pounds, which is 85 into 6, 510 pounds. So plus trip fuel is 510. 10. So 4,500 plus 510, 5,010 pound. In case of zero fuel mass, the formula is maximum zero fuel mass plus fuel on board, which is equal to 4,400 plus fuel on board, that is 110 US gallon. Convert 110 US gallon into pounds, you get the answer 660. So 4,400 plus 660 is 5,060. Now out of these three values, 4950, 5010, 5060, the least value is 4950. So that will be our regulated takeoff mass, 4950. Use the formula. Takeoff mass will be is equal to payload plus DOM plus fuel on board. So 4950 will be equal to payload plus dry operating mass is equal to your basic empty mass plus variable load. Now what is basic empty mass? It is 3200 plus variable load 200 pound plus 190 pound 390. So 3200 plus 390 is equal to 3590. 3590 plus 660. So payload will be equal to 4950 minus 3590 plus 660, 4250. So that is equal to 700 pound. So the correct answer here will be option Charlie, 700 pounds. Okay. So question 19 is 700. Next, question 20, the last question for this lecture. Again, similar question, performance takeoff mass is given, maximum takeoff mass, zero fuel mass, landing, performance landing, basic empty mass, variable loads given. Okay, so let's start. Step 1, key columns for takeoff, landing, and zero fuel. In the takeoff mass, you're going to select a value which is less of performance limited takeoff mass and maximum structural takeoff mass, and that will be equal to between 7,500 and 7,750. 7,500 is less, so write 7,500 here. Next, moving on, in case of landing mass column, you have to select that value which is less of performance limited landing mass and maximum structural landing mass. Add trip fuel to that, so that equals to, now between 6513 and 6400. 6400 is the less value. So write 6400 plus trip fuel. Now what is trip fuel? Trip fuel is 95 US gallon. So 95 US gallon will be equal to 95 into 6 pounds. 95 into 6 is 570 pound. So 6400 plus 570, 69070. Zero fuel mass formula is maximum zero fuel mass plus fuel on board. So zero fuel mass is 5,900. Fuel on board is 150 US gallon. So 150 into 6, 900 pounds. So 5,900 plus 900 is 6,800. Now, out of these three values, 7,500, 6,970 and 6,800, 6,800 is the least, and that becomes our regulated takeoff mass. Moving on, regulated takeoff mass will be equal to DOM plus payload plus your fuel on board, right? Substituting the values, takeoff mass is 6,800, dry operating mass again not directly supplied. They have given basic empty mass 3150, variable loads 200 and 190, which is 390. So 3150 plus 390 is 3540. So your DOM becomes 3540. Payload to be figured out, and fuel on board is 900. So plus 900. Payload will be equal to 6800 minus 3540 plus 900, 440. So payload is equal to 2360 2360 pounds. So the correct answer will be option Charlie. 20 is. So with this question, we come to the end of this lecture. I hope you have understood all the questions that I have solved in this video lecture. If you have any questions or doubts, do let me know in the comment box. I suggest you keep practicing more and more payload questions so that you gain confidence and you become expert at that. These questions will definitely be asked in any exam, CPL, ATPL, airline exam. So practice won't go waste. All the best. Subscribe to this channel and share this video with your friends. See you in the next video lecture.